Good morning, everybody. So I'm from the European Commission. So I'm a bit odd animal, I guess, here. I'm a bit from another angle. We are a funding body. So we are, and I will introduce to you the Future and Emerging Technology program of the research program of the Commission, which is about funding exciting future technologies based on latest advance in science. So quite a few of those of people which are participating, in fact, to this FET program have been speaking yesterday and today, later on today as well. Ultra Haptics was related to that. The seed about data mining is also a FET project. There will be a speaker this afternoon, Karl-Heinz Meyer, who will speak about neuromorphic computing, which is also financed by our scheme. So there were quite a few. There was also the Ascent with Martin Reising, which was presented yesterday, which is another of our FET project. So a lot of the topics which you have touched upon are, if they are sufficiently futuristic and science-based, they are eligible to what we are funding. So let me introduce a little bit this Horizon 2020 program. It's a big European funding program for research, and it is based on 3 pillars, as I said. One is the societal challenge, and that's more short-term applied research for solving the big societal challenge like health, environment, sustainability, energy. You have, on the other side, the industrial leadership, which is really about technologies which research for industry needs, what industry is looking at in the research pipeline. And in the middle, you have this excellent science, and FET is part of that big central bubble, which is about science. And it has a specific role there. It has really to link science with future technology. Our budget for the 7 coming years is 2.7 billion of euros, which will go into that. The overall Horizon 2020 program is 77 billion euros. So that's a big animal, which is not so well known, but which is very based on very successful history of research program, which has enabled science and people in Europe to collaborate for research. Within excellent science, we have some brothers. Some of them might be more well known to some of you, like the European Research Council, which is really about excellent in science, individual grants for the best researchers in Europe. You have the Marie Curie Action, which is financing more the postdoc, for instance, and doctorate grants in Europe. That's also individual grants. You have also this research infrastructure. FET is about collaborative research, so we are not about individual peoples, but about enabling collaborations between people for future technologies. So FET support new ideas, new research ideas to discover the technology of the future. The more futuristic they are, the better they are for us. And this is what we are looking for. We are mainly supporting multidisciplinary research because we believe there's a huge potential for future technology with making cross-disciplinary collaboration. I mean, the example about swarm robotics and health and understanding the swarm in nature with the birds, applying that to technology, and then transferring that into the body to cell swarm is a very nice example of this multidisciplinary and what it can lead to when you get the best people across discipline to collaborate. So our scheme is about collaboration, as I said, and it's about high-risk ID, stuff which are maybe a bit unthinkable. Think about the birds and get into the cells of the body. That's maybe a bit long shot, but this is the kind of stuff, of high-risk stuff that we are financing. So the FET mission is to turn Europe's excellent science base into a competitive advantage for getting new technologies and opening up new technological possibilities in Europe. It's also a program to create a nice environment in Europe to do this type of research. So it's also about providing funding and also enabling collaborations, exchange of ideas within Europe, and providing opportunities for doing this kind of research in Europe. So FET is a bit of a new actor. It's not a new actor, in fact, because we are operating since 20 years, but we are getting much bigger now. We are much more visible. We will become much more visible on the European landscape of funding of research. And today you might know about Marie Curie, you might know about ERC, about Erasmus. Our objective is really that you get to know FET in the same way and to grasp all the opportunity you can get there. We are open to any technology. We used to be based on information and communication technology, so multidisciplinary science to feed future technology, future information and communication technologies. Now we are opening up to any kind of technologies. We do small-scale and large-scale activities. I will say a few words about that. We try to have a lean and fast submission system so that the ideas can get quickly looked at, quickly financed, and can make their way. We have a number of shared value into the FET program. It's about, as I said already, collaborative, multidisciplinary research. It is about visionary ideas. It's also foundational research. The idea is to create a foundation which can open up multiple possibilities. It is still about technological innovation. It's focused. It's not about whatever, about science for science, blue sky research. It's really about getting some ideas for future technologies. So we are operating three schemes. The FET Open scheme, which is, I will say a few words about each of them, which is completely open to any ideas. We have the proactive scheme, which is some thematic calls on some areas which we want to stimulate or get a critical mass of project on in those domains. And we have the new program, which are the flagship program, which are very large-scale initiatives. And Karl-Heinz might say a few words about it because he will speak this afternoon and is very much involved in one of the two flagship initiatives that we have now. So open is open. So this is this FET Open program is very popular because it's open 20 hours per day along the year. At any time you can submit your ID. And every 6 months we have cut-off dates. We collect all the IDs and we finance the best. It's a very competitive scheme, but there's quite a lot of money which will be put into that one. Within the 7 coming years, there will be 1 billion put on this open scheme, and we will launch quite a huge number of projects, probably about 300 to 400 projects under this open scheme. So for the 2 years to come, 2014, 2015, there's 160 million which will be financed. So this is our first scheme. So we work based on 15-page proposal. So you just take a piece of paper on your table, you write your ideas, you elaborate it a little bit in 15 pages to be convincing because it's still very competitive. And based on that, we decide on the financing of them. For the rest, these are the criteria which we use for evaluation, but really the ID, the authentic quality, is really the essential of what we look at. So we finance typically some 2 to 3 million projects for a 3-year period with collaboration of typically 6 partners across Europe. That's, I would say, the average, but the minimum is to have 3 partners. A good idea, a smaller project with 3 partners is clearly as well very welcome. This is about the FET Proactives. FET Proactives, they are thematic initiatives. These are the list of the thematics call we have done in the last few years. They go in very different directions. Some of them are about quantum computing, about atomic molecular computing, about human-computer confluence, about social intelligence, about I guess most of the topics which were discussed, you will find them back somehow under one of those initiatives. Another very important area is the convergence of biology and technology, neurology and technology, what we can open as new possibilities by mixing living technologies with artificial systems. Flagships, we have launched recently 2 big programs. So those are not individual small projects, but they are very large programs. These are 10 years programs. We have one which is on graphene. So graphene is a very smart material which was discovered a few years ago in UK, in fact, and which led to a Nobel Prize to two researchers in Manchester. And this material has exceptional capabilities. But today, okay, we know it has a great potential, but okay, nobody can do anything yet with it. So this flagship initiative is to give the chance for 10 years for a large consortium of academic institutions and industrial partners in Europe to look at what we can do out of graphene and see if we can move it from the academic to a potential industrial application within the coming years. The promises of graphene are huge. You can get electronic papers, you could get a bendable smartphone, enhanced solar cells and battery, lighter and more energy efficient airplane. And these are just a few of the potential applications which you could imagine from that kind of technology. So this is the first one. The second one that we are financing is the Human Brain Project. This is also a large-scale program for the 10 coming years. And this, the objective is really to get all the knowledge that we have today about the brain, to put it together into some model and some simulation to be able to do for the first time the first simulation of the entire brain within the 10 coming years. This is a very ambitious program which could help us to solve and to understand the brain and solve a number of diseases, for instance, which cannot be understood yet. The brain remains the main big secret for humanity, and this is something which we all want to understand better, and it can open up a huge number of possibilities. As part of this Human Brain Project, we have a part on neuromorphic computing, and this is what Karl-Heinz Mayer will speak about this afternoon, and which is about, okay, the brain is a great computer. Can we get inspired by that? What kind of neuromorphic chips we could get in the future which could mimic the fantastic capabilities of the brain. So overall, you can look at our portfolio of projects, which is available on the web. So if you Google digital agenda and FET project portfolio, you will be able to zoom into the 320 projects that we have launched in the last year. So most of them are still ongoing. And then, as I don't have very much time, I will take just one or two examples before ending my talk. One of them is about this artificial hand, which they call, in fact, the life hand, which came into the top of the news a few months ago, because it's really the first time that real-time sensory feedback was provided between an artificial hand and the human body. And which was bidirectional. So you could, with your brain, command the artificial hand, and you could also have tactile sensation coming back from the hand, so that you could know whether you were grasping a tough object or a smooth object, and so on. This is really a breakthrough, which in fact was based on a huge effort in research, of multidisciplinary type of research, with robotics, neuroscientists, algorithmic software, whatever. So this is the type of stuff that we are funding. In fact, we funded 10 years ago the CyberHand project, which had this visionary goal. This project failed to do it. So they opened up the way, but they were not able to make it in 3 to 4 years. There were another project, Neurorobotics, which was able to do the first brain to artificial hand interface, so the one-way direction. And now with this life hand, We are still financing them in the context of other projects, which are still about implants and connecting with the nerves. But now they have been able to release this bidirectional for the first time, and they are leading the way in the world in what we could do in the future with those kind of artificial hands. So this is one example. I'm afraid I don't have too much time to go to the others. Just maybe that one, brain-to-brain communication, that made the news in the last 2 weeks, in fact, because they were, for the first time, able to do a transmission from brain to computer and then computer to brain of information from India to Europe using those specific devices which can read your brain and then transfer information into another brain. So this is also coming out of a project that we have been funding, the HIVE project, which was about hyper-interaction viability experiment. When we selected that project, most of the experts said, this is crazy, they will never make it. Okay, but we will still give them a chance. And now it's something which, yes, people think we are clearly moving on towards that, and there will be possibility in the future really to do this interaction, new sensory, for instance, that you could get into your brain without any sensation, but just by interaction with your brain. So this project is interesting because it's led by a research-intensive SME, Starlab, which is based in Barcelona, and which has been driving the driving force of this project together with academic partners. And it is a good example of the kind of stuff we would like to see into FET. This project led to another startup, which is Neuroelectric, which is commercializing the two devices which enable to do brain monitoring and brain stimulation simultaneously, and which is a unique device which is now available for researchers to make research into those topics. So this was it, and okay, I will have to skip the others. This one is about Plantoid. If you want to know about it, you can come. They were at the RE.WORK conference in Berlin, and they are basically developing a robot which will mimic the plants. The plants have incredible capabilities. They have no brain, and they do huge stuff, very impressive. What can we learn from them? This is what this project is about. So okay, let me skip that. Another one with an SME as well, which is about 3D cell culture. The idea is really to do body-on-chip experiments, so really to have on a chip the cells of your heart, of your liver, and so on, make an ecosystem of how they behave and test some drugs on that. That's really what is this concept of body-on-chip. And this is a project that we are financing, which is really moving to realize this breakthrough. So this is it. Just to conclude, so financing opportunities, the FET Open is a call which is currently open. There are deadlines every 6 months. The first one is in 2 weeks from now. So if you still want to put your ID in, you should be very quick. But there will be opportunities in March, September, and for the coming years. At any time, you can come to that scheme. The funding there will increase radically in the coming years, so there's quite a big opportunity for projects there. The others, one which are there, the proactive are closed for the time being. We will launch some new one in a few months. And then we are financing also an initiative on high-performance computing, but I will not speak about it. And we have this flagship program, which is a bit more restricted because it's an existing very, very large consortium, which we are financing every 2 years with new, fresh money. So this is what I just wanted to say in a few words to introduce to you the Future and Emerging Technology program from the European Commission. Thank you.
Thank you, Aymard.